Hello, and thanks for returning to Introduction to Operating Systems and Virtualization. My name is Scott Neal. Today we are going to be focusing on replicating virtual machines. In today's lesson, we're going to be looking at ways that we can replicate machines. We'll start off by a brief review of some of the files associated with virtual machines. Then we'll move into cloning, templates, and snapshots. And before we finish up, we'll talk about some identifiers that you should consider changing if you're going to be replicating virtual machines. We'll be looking at UUIDs, SIDs, and then we'll talk about how Sysprep can play a role in that, particularly in Windows environments. So if we go back to the very first lecture or so, when we were talking about virtual machines in this series, we defined some files associated with typical virtual machines. And if we go back and review those, we will think about things like the configuration files. All virtual machines do have configuration files. For VMware, of course, the extension on VMware files is the .vmx file. If you want to launch a VM from a folder, you typically find the configuration file, that .vmx file, and you can double click on it and your machine will launch. If you are in Hyper-V or VirtualBox, however, those virtual configuration files are HTML files. And they're not stored as nicely as they are in VMware products. In VMware, typically, if you go in and find the folder for your VM, typically all those files that are associated with that VM are nicely and neatly stored there. However, in Hyper-V, we may have the configuration file stored in the typical virtual machines directory, but the storage is going to be somewhere else on the device or on the file system. Typical setup. So it's kind of important that you are aware that these files can be spread out across the machine depending on the vendor you're working with. Disk files, of course, or data files are going to be associated with VMs as well. If you're using VMware, those are .vmdk files typically. You can have one file or multiple files. And once again, in Hyper-V, that's a more complex question, as data can be stored a number of different ways. There are also additional files that represent a dynamic or functional state of any typical VM, such as the log files or lock files. Say you've got the VM in suspended mode, it may have a lock file associated with that. Paging files, and certainly even snapshot files, which we'll talk about shortly, are all files that you may have to look for if you're thinking about doing a manual relocation or copying of a virtual machine. So we're talking about cloning today, and a question that was posed to me by a student was, why not just copy the folder? I mean, why don't we just copy it? Well, most applications of course do provide utilities for cloning virtual machines, and they do so for a reason. And VMware, my students, we use VMware a lot in our courses. And VMware does a great job of conveniently storing most of, if not all of, the relevant VMware files in its own folder. However, other vendors, as I just mentioned, they distribute VMware files throughout the system. And Hyper-V, because Hyper-V is very flexible and offers a very realistic interpretation, virtual interpretation of the real physical world, Hyper-V may not even use a virtualized storage container. It may actually connect to a physical storage device. So even though VMware does a very nice and clean job most of the time for its virtual machines, all these other vendors may not make it easy for you if you're thinking about just making copies of these files and distributing them elsewhere. So cloning is a way for us to ensure that all of the relevant files associated with a particular VM are going to be compiled for that new VM that you're going to make a clone of. Once cloning has occurred, the original VM, the VM that you have cloned, is going to be referred to as the parent. The new VM, the clone of that original parent VM, we're going to call that the child VM. So if you hear the word parent and child, you kind of have an idea of what we're talking about. There are two types of clones. associated with virtual machines. One of the clones, the full clone, is really where we go in and create a completely independent copy of itself. Once complete, that new child VM is going to share absolutely nothing with that parent VM. That makes it very versatile. I can move it pretty much anywhere I want to from that point forward. And there are some caveats to full clones, however. They do take a lot longer, several minutes in some cases to build, whereas linked clones generally are a lot quicker to build, but they have their own issues as well. Speaking of linked clones, they are made basically from a snapshot of the parent, and we'll talk about snapshots momentarily. They do and must have access to the parent after they're created. All the files available at the time of the snapshot being created are now available to the clone as well. Linked clones do require less space because of this. They take less time to complete, and they're good for their own set of things. If you want to do testing, for instance, if I have a bug that an engineer has identified, they may want to replicate that virtual machine and then create clones for people to work on the bug off of. There are limitations. When you think about moving a clone, that VMware workstation application is going to have access to both the parent and the linked clone in order for that linked clone to work. Speaking of clones, one way that we can ensure that, particularly with linked clones, that the parent is not interfered with is to create a template. A template really is just a master copy of a virtual machine that can be used to create as many clones as you want. VMs that are converted into templates, however, can no longer be turned on. They're not easily altered, so be sure that you have that VM in the state that you want it in prior to making it a template. We often use templates as a way of configuring a reference image, or sometimes referred to as a golden image. A reference image is really just a pre-configured machine, and we go back to physical machines. If I'm going to distribute the same machine, whether it's a physical machine or a virtual machine, to say 100 users in a department, and I know that those machines all are going to have Microsoft Office, Adobe PageMill, Acrobat. We're going to have some configurations for their web browser so they can access SAP and that kind of thing. I can build a box. I take a box off the shelf, I build it exactly the way I want it, and then in the old school way of doing this, I would use some sort of cloning software like Clonezilla or Acronis or Ghost to take an image of that box. That box, then, we refer to that as a reference image, but it's also a template because we're not going to alter that box, or at least not very often. We'll typically take that box and we won't even put it into production. We'll put it on a shelf, and in case we ever need to go back and alter that image, we'll pull the box off the shelf. We'll say a good example will be adding patches or updates. So we'll take that box, we'll add updates and patches to it, and then we will re-image it again. And then we can use that image to distribute that image to other boxes on the network. Well, we do the same thing with virtual machines. We can take a virtual machine, we can build that virtual machine out just the way we want it for our 100 users. And then once we have approved all the applications, make sure everything works, patched it up the way we want, generalize it through something maybe like Sysprep, which we'll talk about later, we can then take that, clone it as many times as we want, whether we want to do that as linked clones or as full clones, and then distribute those clones to whoever we please. A template offers basically a more secure way of preserving a virtual machine configuration that you want to deploy as many times as you want. So snapshots are a different animal altogether. Snapshots are designed to capture an entire machine state at a moment in time of a life cycle. And snapshots are going to allow the user, if at some later point in time that machine gets corrupted, Maybe that machine got hacked into. Maybe there's an application that got messed up in the machine. If we've taken a recent enough snapshot, we can revert back to that snapshot to that point in time prior to the error in configuration or when the corruption occurred. So it gives us really a quick and easy way to revert back to a moment in time on that box. Now, with that said, it's real easy for administrators to confuse snapshots with backups. Snapshots are not backups. Because snapshots are generally stored on the local machine, what happens if that machine gets wet and is destroyed? And not only that, but if the parent machine on that gets messed up in some way, there's no guarantee that even trying to use a snapshot is going to salvage that machine. So we still need a more traditional backup solution for our VMs, similar to what we would do in physical machines, despite the fact that we are taking snapshots. With that said, snapshots are great for disaster recovery. They are great for going back and doing a very quick reversion if we need to go back to a certain point in time. So don't exclude snapshots, even though you still have to have a backup solution. Snapshots lock the original virtual machine's disk. It's going to create a child, and then that child disk is going to be changed and written to. And when the user decides to revert back to the snapshot, that child disk is going to be erased. The changes are going to start over again. And we can have multiple snapshots, by the way. We can do that, and we can create a very complex, sophisticated series of snapshots that can be used to, maybe we're doing specific testing on a virtual machine, and we are looking at different points in time on that machine. So we can do a lot with snapshots. Deleting a snapshot is going to remove the child disk altogether. Those changes will be gone, and it will allow the original disk to be written to once again. And we can also merge snapshots into the virtual machine. That's going to collapse the changed blocks back into the original disks, and once again that disk will be written to again. So there's several different things we can do with snapshots. And if we know that we've got a dozen snapshots that we're never going to revert back to again, we can merge those back into the machine, clean up the storage on the box, and it will still allow us to create snapshots again in the future. So getting close to the end of the lecture, very quick lecture today. So there are some identifiers. There's some unique things on each box, whether it's a physical box or a virtual box, that should be considered when we are talking about replication or taking a clone or a reference image and then deploying an image of that across our network. So one of those, particularly in virtual machines, is the Universal Unique Identifier, or UUID. So VMware, Microsoft, in some cases, they use UUIDs or GUIDs. One of the nice things about UUIDs is that it's a 128-bit number. Anyone can create a UUID and identify anything pretty much with near certainty that that identifier will not be duplicated. I think they say that there's virtually 100% guarantee that no UUID will be duplicated up until the year 3400. So if we're around in the year 3400, kind of like Y2K, maybe we'll have to find something to subvert UUIDs. But we're good for a while on those. VMware particularly uses UUIDs to identify virtual machines. Another common identifier that you may have heard of is the security identifier. Very common in Windows NT based machines. They're abbreviated as SIDs, SID. So when you hear people talking about SIDs, they're really talking about security identifiers. It is immutable. We use SIDs in domains to identify users, user groups, other security principles, computers, and VMs, of course. And SIDs are going to be useful for a variety of things. We can use them for troubleshooting issues, for security audits. We can use them for Windows Server and domain migrations, and access control lists use them to identify users. So at the bottom of the screen here you see an example of a SID. You can see it's kind of a long number. I'm not going to bore you to death. Some of those numbers do mean something, like the 5 is a number of, it's a long story. Anyways, beyond the scope of this class. Sometimes you'll see a SID if you are looking at perhaps a file properties screen, a security tab for who's got permissions to a file, and if a user has been deleted, you may see this long number there that represents or did represent that user. So SIDs have been since 2009. Before 2009, it was common practice for network administrators to change the SIDs on all machines. Sysinternals, which is a suite of utilities currently available through Microsoft. They bought Sysinternals many years ago, so they're rolled into the Microsoft family, so to speak. But Sysinternals still puts out a list of utilities that are very useful to network administrators. One of those utilities that was around until 2005, 12, whatever it was the SID changer. I still keep a copy of the SID changer because I am not entirely convinced that Microsoft knows what they're doing. Microsoft came out in around 2009, 2010, and they said, guess what? All these years that we've been changing the SID on machines, we really didn't need to do that. There really isn't anything relevant to changing the SIDs on these boxes. So they decided at some point to pull the SID changer off the Sysinternal suite. There has been, and if you go online and Google up SID or does a SID really need to be changed, you're going to see all kinds of arguments and examples of where changing the SID or not changing the SID did manifest itself in some sort of an issue. So there's always been this controversy about whether or not SIDs need to be changed on a machine. So I just wanted to throw this out. It seems like a good time to talk about this because you will hear network administrators talk about UUIDs. Computers, VMs are not the only things that use UUIDs. Storage devices use UUIDs and so on. So if you are looking at or hear UUID or SIDs in conversations, you'll have some idea of what they are. But these things need to be changed on new boxes as a general rule, particularly UUIDs on VMware. Another thing that you'll be might be aware of is that if you move a VMware or a VMware virtual machine, or you change the directory that a virtual machine is in VMware, it's going to automatically it's going to change the MAC address of the virtual adapter for that machine. I don't have that in my notes here, but it's a good thing to know in the event that you take the machine and move it or whatever, and maybe that machine is in your DHCP server reserved with a MAC address. One of the things you're going to want to double check is to make sure that that MAC address hasn't changed, because if it has, then it's not going to be updated in the DHCP server. Last but not least, since we're talking about things that need to be changed, what's a way that we can do that? Well, one tool, particularly in the Windows world, there's one tool that we use as a preparation tool for deploying Windows operating systems, and that's Sysprep. Sysprep has the ability to alter device drivers, add applications, in addition to providing identification information and changing that identification information on boxes. And Windows operating system installations are going to include a lot of unique elements each time it's installed. So basically, if you are going to deploy a Windows operating system, and ever since NT came out we've had this issue, then you're going to, as a general course of action, want to run Sysprep on your reference image. And that reference image can be virtual or physical. There are things that definitely need to be changed or removed, and that includes, but is certainly not limited to, the computer name, the security identifier, and the driver cache of the machine, and of course the profiles on the user profiles on that machine as well. So Sysprep allows us to generalize your reference image, and then it will, through the use of what we call an answer file, we can use Sysprep once again as that image is being deployed to each individual system. The answer file can consist of customization items for each of those boxes, including the computer name, whether it's on the domain, and so on. So beyond the scope of this class, but if you are interested in that kind of thing, we will be looking at it not in the first computer course that I do here online. The second course, the advanced course, will have a lot to do with Windows deployment, WSUS, and things like that. Alright, so that's all I really have. Just to summarize, virtual machines are composed of files. Can't say that enough times. And those files contain the virtual machine configuration settings, all the data, and of course any current state that that machine may be in. If I want to create multiple VMs, the best way to do that is through cloning. Cloning creates copies of a parent VM, and if I'm going to be cloning a lot of copies and I want to make sure that all of those copies are going to be identical, it may be wise to take that parent and create it and turn it into a template. That will ensure that the parent cannot be altered, and it's going to facilitate rapid cloning. Likewise, as a matter of good practice, snapshots should be made of your virtual machines. It's going to save the current state of a virtual machine at that particular point in time. But the great thing about it is if the box is later corrupted or some sort of issue develops, we have that snapshot as a means of reverting back to that original configuration state. Some of the identifiers in virtual machines should be changed. If you're going to be replicating those machines, things like the SID, UUID of the machines, those machines should therefore be generalized, basically Windows machines, and we can use Sysprep to facilitate that generalization if we're going to be deploying Windows in a Windows environment. Alright, that's all I have for today's lesson. I hope to see you next time for lesson 13. Have a great night.